Hampshire College astronomer Dr. Salman Hameed, Mr. Universe, here at your kitchen table in Amherst. It's possible that there is a black hole that is in our solar system and going to whisk us away in minutes. Is this what I'm learning from the Hubble Space Telescope and NASA? There is a rogue black hole out there?
Okay, so first of all, no and no.
Okay, good. I can breathe a little bit easier and enjoy this cup of coffee.
But this is a really cool story. And what I want to highlight is, I know everybody is off to their new toy. Everybody's talking about James Webb Space Telescope and da-di-da-di-da. But don't forget Hubble.
It's still up there working.
It's still up there working, and you can find some really cool stuff. And remember that James Webb Space Telescope is also complementary to Hubble, meaning to say that it works in different wavelengths, different light. So this was actually a really cool story where astronomers from Yale, actually led by astronomers from Yale, they actually found a runaway supermassive black hole.
How do you find a black hole when light can't escape a black hole? How do you see it? And where is it running away to? And why don't I need to worry about it running away here? We wouldn't even see it coming.
Okay, so all of these things are really interesting. So let's go step by step. First of all, you don't see the black hole directly, but you see black hole indirectly. So stuff that is falling around it. Usually, that's what we know about it. And so, as for example, you remember the image of the event horizon of the black hole? That was not the black hole itself, but the light that was right before it goes into the black hole. Astronomers had imaged it.
That's Wookiee. It's trash day. It's sort of like ring around the black hole.
That's right. And also that's how astronomers have detected black holes in general, and that is through an accretion disk, meaning to say that you have material that is falling into the black hole, but before it falls into a black hole, it gets heated up so much that actually it radiates. In fact, it radiates very highly. That's how we detect. And some of the brightest objects, the centers of galaxies, those have supermassive black holes, and we see these bright centers because they have these accretion disks, meaning to say material swirling around this black hole, and before it goes in, the friction makes it really, really hot, and that's what we see. So we know black holes exist because we have seen these accretion disks. We know black holes exist because we have seen these light photons right around outside the black hole. So that is not the issue. And we also know there are different types of black holes, because there are black holes the size of our sun that are sort of like, end stages of these big stars. And then we have these supermassive black holes that reside at the centers of galaxies, including, for example, at the center of our galaxy, which is about 4 million times the mass of our sun. But there are big ones, and actually recently, which we are not talking today, but recently astronomers also detected one that is about 30 billion times the mass of our sun.
Wow.
But that's not a runaway black hole. This is a cool story because this is very unusual. You don't find runaway black holes because it's very hard to detect them. So astronomers found a a region of the sky, a galaxy that they were looking at, and they found a big streak over there. Now, initially, as you would think, they think that, hey, maybe there's a problem with the detector. Maybe there are something called cosmic rays. These are high energy particles that actually are roaming around. And if you are taking astronomical images, deep exposures, you're often bombarded by those. And so you have to correct for them. You occasionally see that and you correct that streak. But in this case, that streak was not a cosmic ray, but an actual line of stars that are being formed, and they're away from the galaxy. So there is a galaxy, and then there is this long line that you can actually see that is in there, and that contrail, that's what astronomers also define it.
Chemtrail?
Okay, kind of but except that this is a contrail of newborn stars.
Wow.
And that's 200,000 light years long. So roughly twice the diameter of the Milky Way. So you have a galaxy, and then you have this line of these newborn stars. The question was, how did this line of stars got formed? And this is puzzling because normally you don't see that. So this is where I was talking about that sometimes you find these unusual things, and for that you require unusual explanations. And so what astronomers think is that there is a supermassive black hole. They estimate that it's about 20 million times the mass of our sun, so much bigger than the supermassive black hole at the center of the Milky Way. And that got ejected from the center of its galaxy. And as it is going through intergalactic space, it is compressing gas. And when it compresses gas, it forms stars. Basically, it forms stars in its wake. You can think about that.
So it's not eating things. People think black holes eat things. But what this black hole is doing is actually building things.
In fact, in this particular case, it doesn't have time. That's what astronomers think, because they think that it is actually moving really fast. Their estimate is about 4 million miles per hour. That's how fast it's going. So it's very fast. Or sort of another way is, and again, this is sort of like the estimate, that it would take about 14 minutes for this black hole to go from Earth to the moon. Okay, that's how fast it is going, which is, everything is fast on the global scale, but it is moving
fast. The galactic scale even.
And it doesn't have time to actually absorb material, but rather because of its high speed, it compresses gas, and stars form from compression of gas. And so it is leaving behind these new stars, and there are a lot of them, because you can see that even though this whole system is actually a few billion light years away, and you can still see the galaxy and this trail of stars.
The NASA article that you sent me that talked about the Hubble telescope mentioned Pac-Man, and it does feel like that. I want to see if I can find that. And yeah, rather than gobbling up stars ahead of it, like a cosmic Pac-Man, the speedy black hole is plowing into gas in front of it to trigger new star formation along a narrow corridor. It's sort of like reverse Pac-Man. So you need another rogue black hole to come behind this black hole and eat those stars that this Pac-Man creating galaxy black hole has created.
Well, that would be cool. But there is more to that story, and there are binary or two black holes on the other side of the galaxy, because that is related to how this was formed. Because you asked this question, well, how do you get a runaway black hole? Because
what kicked it out of its galaxy?
You would expect supermassive black holes. These type of black holes are in almost all big galaxies. So that's not a surprise that there is a supermassive black hole at the center of a galaxy. But what is surprising here is that it's running away from it. So the next question is, why is it doing that?
It's afraid.
Exactly. So what astronomers think, and this is where they look for various explanations. Remember, they're not seeing the black hole itself. What they are seeing is this trail of newborn stars that is sort of like pointing away or in one direction from the galaxy, and they can figure out sort of like where there are newer stars versus older stars, and there is a particular direction in there. So what they think is that this black hole got ejected because there are two other supermassive black holes at the center of this galaxy.
So the gravity between these two other black holes just shot this other runaway black hole out of the galaxy to go and create its own trail of stars.
Right. So just here we are. This is just so cool. Absolutely, So they had what they think supermassive black holes reside in centers of galaxies. So we expect, or astronomers think, that there were two galaxies that collided with each other. Galaxy collisions happen. Milky Way and Andromeda galaxy is also going to collide, and they both have supermassive black holes at their own centers.
Is that going to happen soon?
No, but in a few billion years, so don't worry about it today. And so here, 50 million years ago, astronomers estimate that two galaxies collided. They both had supermassive black hole. So you formed a binary supermassive black hole at the center of this new merged galaxy. All well and good. Two black holes can go around in orbit. We know that they sometimes collide together, and that's how we have detected, for example, gravitational waves from these collisions. But a third galaxy with a supermassive black hole also collided there, and now three is a crowd.
Yep.
Because the orbits, when you have three objects, they can be chaotic and they can be unpredictable, and that can lead to the ejection of one or both of these, or all three of those black holes. And astronomers think that this is what happened. We don't know which one of those, the new one that got ejected, so the new one came in, or it replaced the ones that were already there, and it ejected one. And so it got their momentum when they were orbiting, and it got ejected out, and that's what we are seeing. And as it got ejected out at very high speeds, in fact, astronomers estimate that it has been 39 million years that it has been going out on its spree. I would say star formation spree.
It's sowing its wild oats.
Exactly. But, and here is what I love about it. They also think that there is a faint detection of another streak on the other side of the galaxy. And they think it's because the other two black holes, and that is related to conservation of angular momentum as well, they think actually they got kicked out on the opposite side, and those are also creating some stars. And so here is a case, again, that we think there are a couple of these runaway black holes that are actually pretty nice because they are forming new stars. And so you can imagine that you can have those stars, you can have planets around them, maybe some of them may have life, and they may trace one day, hey, how was our solar system formed? And they may figure it out one time that, you know what? Children, gather around. Let me tell you, there was a black hole in that galaxy that we see. It's quite far away because we are not part of it. But there was a black hole that ran away and created our star and their planets, and then we evolved, and now we worship this supermassive black hole.
Awesome. Is there more?
I think, well, I can just add one more thing to that, and that is, as you can imagine, this is an interesting object, and it's going to be a target for James Webb Space Telescope as well. But give Hubble some love. I think Hubble is still doing amazing stuff.